Hello everyone, I am Dr. Venkateswararao. In the last video, that is concept of pH part 1, we came to know the definition of pH, and the definition of pH is negative logarithm to the base 10 of concentration of H plus ions. That is the definition that we came to know from the last video, and we can write this equation as logarithm to the base 10 concentration of H plus ions inverse. If you take this negative charge to the power of H plus ion, this will be written as this can be written as log base 10 concentration of H plus ions inverse, and this can be written as log base 10 H plus ions inverse, that can be written as 1 by concentration of H plus ions. Therefore, pH is, from this equation we can understand that there exists a negative relationship or inverse relationship exists between pH and concentration of H plus ions. Okay, so pH is inversely proportional to the concentration of H plus ions. That means with increasing the pH value, concentration of H plus ions decreases, or with increasing the concentration of H plus ions, pH value decreases. Okay, so that is pH is inversely proportional to 1 by concentration of H plus ions. Okay, I repeat, with increasing the concentration of H plus ions, pH value decreases. With increasing the pH value, concentration of H plus ions decreases. And we came to know that pH scale ranging from 0 to 14. And the pH scale ranging from 0 to 14. Now we shall see what would happen when we go from low concentration of H plus ions to high concentration of H plus ions. I take low concentration of H plus ions as a 0.01 normal and high concentration of H plus ions as 1 normal. Let us see what would happen when we go from low concentration of H plus ions to high concentration of H plus ions. We know that 0.01 normal, which means that 0.01 normal concentration of H plus ions. This can be written as 1 by 100. 1 by 100, that gives 0.01, and 1 by 100 can be written as 10 power minus 2. And if you calculate the pH for this concentration of H plus ions, negative logarithm to the concentration of H plus ions, concentration of H plus ions, here the concentration of H plus ion is 0.01, this can be written as 1 by 100, and this can be written as 10 power minus 2, and pH of that solution is 10 power minus 2, and the pH is 2 log 10, that is pH is 2. Now if we go with the concentration of H plus ions is equal to 0.1 normal, this can be written as 1 by 10, and this can be written as 10 power minus 1, and pH of this solution, pH is equal to negative logarithm to the power 10 power minus 1, and this comes out to be 1 log 10, and thus the pH value of pH value for this concentration of H plus ions is 1. Okay, now we Already I told you, let us see what would happen when we go from low concentration to high concentration. I start with the low concentration as 0.01 and high concentration as 1 normal. Concentration of H plus ions is equal to 1 normal. We could not write this as in decinormal solution, and in terms of 1 by 10 or 1 by 100, we could not write that 1 normal solution in decimals. Okay, so we can calculate the pH value for this. pH is equal to negative logarithm to the concentration of H plus ions 1. Log 1, that is 0. Log 0. If we go with more concentration than 1 normal, that is, if we go with 2 normal solution, then the pH value would be negative. If you go with the 3 normal, that the pH value is the pH value is negative 2. Right? That means when we go from low concentration to high concentration, here the concentration is 0.01, corresponding pH is 2. Here the concentration is 0.1, corresponding pH value is 1. Here the concentration is 1 normal and the corresponding pH is 0. And if you go with the 2 normal solution, that pH value is negative 2. We get negative value for pH. That is, from this we can understand that with increasing the concentration, pH value decreases. From this we can understand, and then if we go with the more concentrated solution, that is 2 normal, 3 normal, 4 normal, then the pH value is negative 2. But actually we know the pH scale ranging from 0 to 14. We could not see the pH scale with negative values. Therefore, we can understand that Sorensen proposed the pH scale 0 to 14 for low concentrated solutions. So Sorensen, I repeat, Sorensen proposed the pH scale 0 to 14 based on the ionic product of water, and that pH is the definition is given for low concentration, and the scale is given for low concentrated solutions only. That means when we go with the low concentration solutions, the definition of pH is equal to negative logarithm to the base 10 of concentration of H plus ions, and same is true, and the pH scale ranging from 0 to 14 holds good. But when we go with the high concentrated solution more than 1 normal, then we get negative pH values, but we could not see the negative values in the pH scale. Therefore, we can understand that Sorensen introduced the pH scale 0 to 14 for low concentrated solutions. Then you may have a doubt, how can we calculate the pH of high concentrated solutions? Sorensen, for this Sorensen proposed another definition for pH for calculating the high concentrated solutions. That is, pH is that definition for the definition of pH for high concentrated solutions that is given by Sorensen is that pH is negative logarithm to the base 10 activity of H plus ions. Activity of H plus ions. where activity of H plus ions, AH plus means activity of H plus ions or effective concentration of H plus ions. Okay, AH plus is activity of H plus ions, activity of H plus ions or effective concentration of H plus ions or effective concentration of H plus ions. So, activity of H plus ions or effective concentration of H plus ions. In fact, activity of H plus ions or effective concentration of H plus ions means that concentration of free H plus ions. What is meant by free H plus ions? That means here the free H plus ions means that H plus ions apart at large distances. That is, H plus ions are separated by large distances. Okay, I repeat, here the activity of H plus, AH plus is activity of H plus ions or effective concentration of H plus ions. Activity of H plus ions or effective concentration of H plus ions means that the concentration of free H plus ions. Free H plus ions means H plus ions apart at large distances. That is, H plus ions are separated by large distances. Okay. Okay. Activity of H plus ions or effective concentration of H plus ions means that that is the concentration of free H plus ions. Free H plus ions means H plus ions apart at large distances or H plus ions are separated by large distances. When will H plus ions separated at large distances? This would happen only in the case of low concentrated solutions, because with increasing the concentration, I repeat, with increasing the concentration of free H plus ions progressively less because of interionic attractions as the concentration increases. I repeat, with increasing the concentration, the concentration of free H plus ions, means H plus ions are separated at large distances or H plus ions are separated at large distances. With increasing the concentration of free H plus ions would progressively less, because with increasing the concentration, interionic attractions increases as the concentration increases. Okay, so with increasing the concentration, the number of H plus ions increases in the solution. That's why there is no free movement of H plus ions. That means the activity of H plus ions would be less. Okay, so with increasing the concentration of free H plus ions progressively less. Because why? Because with increasing the concentration, interionic attractions increases as the concentration increases. Right. Okay. When if concentration increases, what would happen? The concentration of free H plus ions progressively less. Okay. Then how can we calculate the activity? Therefore, activity of H plus ions can be measured by multiplying the concentration of H plus ions with a suitable activity coefficient based on the thermodynamic measurements. Thermodynamic measurements are based on the movement of H plus ions. Okay, I repeat, how can we calculate the activity of H plus ions? Activity of H plus ions can be determined by multiplying the concentration of H plus ions with a suitable activity coefficient based on the thermodynamic measurements. Thermodynamic measurements for dilute solutions. That activity coefficient is found to be 1. For dilute solutions, the activity coefficient is found to be 1. For concentrated solutions, it get smaller than 1. Okay, so pH is equal to negative logarithm to the base 10 activity of H plus ions. This is the definition for pH for high concentrated solutions. Okay, so here the activity is concentration of free H plus ions. Free H plus ions is progressively less with increasing the concentration. Interionic attractions increases. Interionic attractions among the H plus ions increases. Therefore, activity decreases. But in the case of dilute solutions, activity coefficient is found to be 1. Already I told you, okay, the activity of H plus that can be determined by multiplying the concentration. Activity of H plus ions can be obtained by multiplying the concentration of H plus ions with a suitable activity coefficient based on the thermodynamic measurements. Suitable activity coefficient that is represented by gamma. Okay, suitable activity coefficient that is represented by gamma, and the activity coefficient for dilute solutions, it is found to be 1. So it is found to be 1. Gamma is equal to 1 for dilute solutions. Therefore, for dilute solutions, the activity of H plus is equal to concentration of H plus ions. But in case of concentrated solutions, this activity coefficient it gets smaller than 1. So at the in the case of concentrated solutions, that activity coefficient would be smaller than 1. Then you should substitute the activity coefficient value in this equation. Then you get activity of H plus ions, and if you substitute this activity of H plus ions in this equation, then you get the pH value. But the activity coefficient of dilute solutions is found to be 1. Gamma is equal to 1. Okay, so for dilute solutions, activity of H plus ions is equal to concentration of H plus ions. But in concentrated solutions, activity of H plus ions is equal to actual concentration of H plus ions into activity coefficient. But in dilute solutions, the activity of H plus ions is equal to actual concentration of H plus ions. Okay, so if you want to calculate the pH of concentrated solutions, you should measure the activity of H plus ions. How can we measure the activity of H plus ions? We can measure the activity of H plus ions by multiplying the actual concentration of H plus ions with activity coefficient. Okay, therefore we can conclude that Therefore, pH is negative logarithm to the base 10 concentration of H plus ions. This is the definition for pH in the case of low concentrated solutions, that is less than 0.1 normal, less than 0.1 normal, that is less than decinormal. And the definition for pH in the case of high concentrated solutions is negative logarithm to the base 10 activity of H plus ions. Activity of H plus ions. That means activity pH measurements of high concentrated solutions requires the use of activity coefficient, whereas pH measurements of dilute solutions does not require activity coefficient, because it is found to be 1 in the case of dilute solutions. In dilute solutions, activity coefficient is found to be 1. Okay, so it should be kept in your mind that the definition of a pH, that is negative logarithm to the base 10 of concentration of H plus ions, that is the definition which is applicable to only dilute solutions. Okay, and if you want to calculate the pH of high concentrated solutions, that is more than 1 normal, 2 normal, 3 normal, like that, then that the pH measurements requires use of activity coefficient. So pH for high concentrated solution, the definition of a pH for high concentrated solutions is that pH is equal to negative logarithm to the base 10 of activity of H plus ions. Okay, with increasing the concentration, activity of H plus ions progressively less, because with increased interionic attractions as the concentration increases. Therefore, I repeat, you should keep in your mind that pH is negative logarithm to the base 10 of concentration of H plus ions, that is the definition which is applicable to dilute solutions only. And if you want to calculate the pH of high concentrated solutions, then you should use the definition pH is equal to negative logarithm to the base 10 activity of H plus ions. Okay, and finally you should keep in your mind that activity is equal to actual concentration into activity coefficient. Activity is equal to actual concentration into activity coefficient, and activity coefficient is equal to A by C, and activity coefficient would 1 in the case of dilute solutions. Okay, but in the case of it is in the case of dilute solutions, but in the case of concentrated solutions, gamma is less than 1. Okay, because in case of dilute solutions, gamma equal to 1, we can use the formula pH is equal to negative logarithm to the concentration of H plus ions. But in case of high concentrated solutions, gamma would be less than 1. Okay, so therefore let me sum up this lecture. Let me sum up this lecture. So pH is negative logarithm to the base 10 of concentration of H plus ions. That is the definition that is applicable to only dilute solutions. But when we go with high concentrated solutions, that is more than 1 normal, The definition for pH is equal to negative logarithm to the base 10 activity of H plus ions. Activity of H plus ions. Activity of H plus ions means that effective concentration of H plus ions or concentration of free H plus ions. Free H plus ions means that H plus ions are separated at large distances. This would happen only in the case of dilute solutions. In the case of high concentrated solutions, with increase in the concentration, more number H plus ions number increases. So H plus ions are apart at low distances. So their activity decreases. But in case of dilute solutions, that activity would be their activity coefficient would be 1. So activity coefficient, activity of H plus ion can be determined by multiplying the concentration of H plus ions with suitable activity coefficient based on the thermodynamic measurements. Okay, so I hope you all understand this concept. Okay, this is very fundamental concept that you should know. You should know the difference between pH is negative logarithm of concentration of H plus ions and pH is negative logarithm to the base 10 activity of H plus ions. Okay, thank you. In the next video, we shall go with calculation of pH per weak acids, pH of weak bases. In the next video, we shall see these concepts. Thank you.